So is it me now?
Yeah, unless there's yeah. You
I
go
don't know
ahead,
if there
please.
was anyone else. There's no one else that's got a presentation that wants to do for outside in particular, is there, before it gets dark? Mick?
No, mine's in the garage.
Oh, in the garage? Okay.
Yeah,
That's not too
I
bad.
got plenty of light in there.
Cool. Well, we'll do yours first, Les, and then we can go on to Nick.
Okay, I haven't got Wi-Fi outside, so I've got a presentation and I've taken some photos so we can just talk through the pictures. So hopefully I can share the screen and I know this worked earlier.
Was that at 6:45? Was it as you tested it?
Sorry?
Was that when you tested it at 6:45?
I must have broken something here. I don't know what's going on.
Yeah, you press the share button. It's not.
Oh, here we
coming
go.
up.
Yeah, I've found the screen. I found it. That's all right. I found it. Right. Now. No. Okay, so the function keys aren't working. Can you see that all right?
Yeah, all looks good.
Yeah.
Okay, so I've got a couple of things. One is the brew shed, which you're looking at a bit of now, and the other one is about my kind of kit and process. I didn't know quite what people would be interested in, so the first couple of slides are about the construction of the brew shed. I'm interested in construction of brew sheds. I don't know if other people are. If you're not, tell me and I'll move on, but I'll make it brief.
Very interesting.
So, you're very interested. Yeah. Excellent. So this is about the construction of the brew shed. So on the left-hand side here, now I might be able to actually pull up a little laser pointer. Can you see a little red dot?
Yep.
Oh, wow, that's great. Okay, so concrete raft, as you might expect, some electrical cables here. One of these is to provide power to the shed. The other one is connected to a lighting circuit that goes around the whole garden. We'll come back to that in a minute or two, perhaps. This here is a water feed that comes from our outside tap and provides water to the brew shed area. So this is 2 levels because this is where the brew shed is built. This here is the bar area, and you can see in this bottom diagram here that that's decked. So this top one is where I started all the carcassing for the shed. And if we move on to the next slide, that's me on top, topping out ceremony. I've put the roof on. And you can see obviously there's construction of the shed there. Over here, I've started to line it. And down here, I've clad the shed and put all the shingles and stuff on the top. Building the bar. So this is this bit pulls out from the bar, so it doubles the width of the bar. And I did that because sometimes, very often, we have quite small gatherings of just a few family members. But every so often we do a much bigger gathering and we pull this out and put a new bar top on to extend it. So that just gives us a bit more capacity. And here I've put the top on the bar, obviously thirsty work. And this is the finished article with all the lighting and so on. So that's the lighting bit now wired in on that one. So that's my brew shed.
Lovely.
On the inside, we have to start at this end here, power and obviously all the internal wiring for sockets and things. But these bits here are for cooling within the shed. So from the outset, I thought I want to have some cooling in the shed. This bit is for the shed itself. This one is for the fermentation cupboard. And so in the next picture, you've got, this is a Maxi 310. We heard about a Maxi 310 a moment ago. This is also a Maxi 310. And this Maxi 310, believe it or not, provides the cooling for the whole shed and for the fermentation cabinet, and for the beer python that you can see in construction here. And these, you can't see them on there, but there are 4 product coils on there for cooling the beers, individual beers, even further. And this one device, this one unit, does all of that. And it does it quite well, actually, with lots of insulation. So that was important. This little thing here is an STC 1000, and it monitors the temperature of the space that the glycol cooler is in, because this is all boxed in. And this monitors the temperature inside that enclosure. And if it goes above 30 degrees, it switches on this fan, which exhausts this area to the outside. These are power meters used to monitor the power that's for the shed, for heating, for cooling. And the shed is not just heating and cooling, there's also a fridge on the other side of this wall that's under the bar. So what you're seeing here is the insulation, a beer python for these taps. And I'm sorry to Jennifer, there are more than 4 or even 5. I've got 7 there. And then I clad the whole thing in ply. So this bit here is looking to the left of the door. That's where all the kegs will go. And this bit here is to the right, which is the fermentation cabinet that was at this point in construction. So there is a door on the front of that with 3 inches of insulation on it. So that's temperature controlled, and there, you can't see it in the picture very much at the moment. That's the little heat exchanger, a little radiator that keeps the fermentation cabinet cool. So this is the cooling. In the main shed, this is the radiator, the heat exchanger. Fancy word, it's a radiator. It's a car radiator with a fan on the front. And it's not covered at the moment, but this is the kind of glycol feed that comes from that chiller. So when the brew shed is hotter than I want it, the glycol chiller provides -3 degrees glycol into this radiator, and the fan blows out chilled air into the brew shed. And over here, this is the one that's in the fermentation cabinet, again under construction. That's the thermometer, the kind of probe, temperature probe, that goes back to the temperature controller. And there's a fan actually at this point, the fan is on the back. I didn't realize at the point I was building this that fans do not work on these little radiators in the kind of push mode. You have to have the fan at the front in suck mode. So if you build something like this yourself, that's important because the back pressure prevents any kind of flow through the radiator. If it's here sucking, it sucks the air through and that works fine. So just a point of interest if you decide to do anything like that yourself. This bit up here is the control panel. So that's the brew shed. That's the fermentation cabinet. And I did build a defrost cycle, which is a kind of repurposed timer, electronic timer, you know, the kind of thing that you plug into the mains, then you plug a thing into it and it turns on and off. So I've repurposed it there as a defrost. That's the brewing shed temperature control performance. I won't go into this in any detail, but this is the brew shed, which is reasonably consistent at about 13, 14 degrees. Even when we were getting into the yellow line is the outside temperature. So this was when we were at 36, 37 degrees. I think it was getting close to 38 at this point, and the brew shed was at 16, and it should be normally 14. It was starting to lose control around 30 degrees, starting to just slip a bit. So it went from 14 to 15 to 16.2 at this point. This is where I was actually doing my cleaning out my beer lines. So I had the door open. Okay, so this is the inside. Lots of kegs, lots of pipe work. Secondary regulators, again, the same as I think James was talking about with these kind of cascade or coupled secondary connectors. These ones up here are on CO2. This one is on mixed gas, which is that green canister there. and that's used for the stout. It's nitro stout. This is the taps, optics and so on, and a bit of decoration, and that's just kind of the finished brew shed. Almost finished. I've got on this little space here, I want to fit a snack board. I've bought all the little kind of clips and a bit of white hardboard, white-faced hardboard that will make a little snack board on there.
You're going to have a picture, so as you gradually take off the packets of pork scratchings, it reveals something.
That's a great idea, James. I might pick up that one. I'll credit you, of course. So that was that's the brew shed. So brew kit and process. This is kind of it, really, but I'll expand on it a bit. So this is my store. All my grain, I decided, because everything was in sacks and I had a couple of mice try to break in. So I bought some mouse traps and I decided to remove the problem so that I'm not having to kill mice. So all my base malts are in these tubs. All my specialty malts are in here in these containers. And on the shelf above, I've got all my sugar, lactose, glucose, candy sugar, and so on. Not quite so organized with the hops and yeast, but yeast is all down here, and a couple of other ingredients like protofloc tablets and coriander seeds, that kind of stuff. This is hops that are not yet open, and this is hops that are open. So Arthur, I'm with you on the hops. I've got plenty of hops. Mind you, I've got plenty of grain too. I'm greedy. Water. So this is a 4-stage RO filter. So it's probably the same as what Arthur's got, but it's also got this ionization filter on the end, which removes any ions in the water. This is it in use, these 2 slides here. And this is the pump that I spoke about. So that takes the throughput or production of the RO water from, in my case, 2.5 litres to about 14 litres per hour. It's really worth having. It costs as much as the RO filter. That was about 50 quid, and I think that was about 50 quid. But for the saving on time, for me, it was worthwhile. I don't mind spending 50 quid on something that's going to save me hours and hours of time, even though I'm not actually sitting there doing anything. I just like it to be done. This is what I do all my brewing in. It's a Signet boiler. I've got none of that. I mean, it is stainless steel. It's shiny stainless steel, but I've got not got the fancy stuff that that other colleagues have got that buy these. Well, the good stuff. I've got a cheap Signet boiler. I did change the tap, and on the other end of that tap is that bazooka that you can just about see in the picture there. And this thing with crossed bits in, that's a grain basket. It's almost the same size as the Signet boiler internal dimensions, so it fits quite nicely. I use these kind of drug dealer scales for working out my salt additions, and I guess like most people, it's an ordinary kind of mill with a drill on it, and I use ordinary kitchen scales for measuring out my grain. So on here, where do we start? Okay, so here, I suppose, I've got a timer down here, this thing, and I use that so that the water heats up, so it's ready to start my brew day at about 6 o'clock. Just makes the, it means I can get the brew done by about midday, I suppose, and then I've got the afternoon to myself. The Signet boiler has this nasty little thermostat, which doesn't give you any real control over temperature at all. So I just set that to max and then plug the Signet into the heater socket for this Inkbird temperature controller. And you can just about see the probe here, which goes into the boiler. I just dangle it in and that manages the temperature for me. Over this side, you can see that from that tap, I recirculate through a pump back into the top. And this is the picture of it coming out through that little spray at the top. This little spray thing is to kind of reduce the impact, I guess, of this water on the surface here on the grain underneath. And the idea is, I don't know if any of you have seen Clawhammer. They're a company that in America that make these kind of things, but they cost something like $1,500, which is a bit pricey for me. So I thought I could make something similar. And actually, I did for about £500 in the end, so it was a lot cheaper. But the idea is that through this recirculation, you manage the temperature of the grain bed better throughout, but you're also kind of lautering at the same time, you're filtering. So if you see this picture here, this is the wort that I produce at the end, very clear. And these two pictures are just to remind me that actually I'm probably like most other people, I use a refractometer for hot temperature gravity checks, and just these pH meter, and that's a TDS meter that also does temperature that I use throughout the mash. So onto the sparge. This is my sparge setup. It looks a bit complicated, but as you know, the sparge is really just putting water in, draining the wort out, and trying to balance the flow between the two. So that's kind of what all this stuff does. This is a bucket with some warm water in it, and in there is this thing up here, which is a fish pond pump, which sends the water up this spout to this little elbow, which is connected onto the end of this. Now this is the top of a fermenter, plastic bucket fermenter, just with the middle bit cut out, and some beer pipe going around it, fixed at various points with cable ties. And it's perforated using a needle. So you see here, there's some water. So this thing here is this pump sending the water up here, along here, out through that little spray bit into the tank at the top. So that's my supply. And then you normally take the wort from the bottom. So here the wort comes out. Now here I'm actually doing something a little bit odd. I am continuing to recirculate. So my sparge water and the wort in there continues to flush through the grain throughout the sparge. And that increases the efficiency somewhat. And normally I would expect to get 75, maybe 80% efficiency. It has been as high as 85% efficiency through this mechanism, which is quite good. So then you've got to get the wort out at some point, because if you keep filling it, you're just going to overflow the boiler in the end. And this is my version of a Valentine arm, which comes off that recirculation thing. So the Valentine arm, if you're not familiar with a Valentine arm, allows you to match the outflow with the inflow easily, because whatever the level of the wort is in here, it has an open path here out. So if this point here is lower than the level of the wort, sorry, I can't help saying wort. If this is below the level of the wort, then the wort will dribble out and the level will fall. So all I need to do is, by being able to angle this, I can choose the height that this is against the boiler. And then once I've set that height, no matter how fast the water comes in or how slowly, actually the inflow will be matched by the outflow, because anything that goes over that level then dribbles out or pours out, as the case may be. And this is just a stick to hold it at the right angle, so it doesn't kind of just drift down slowly and start to empty the boiler. So that's my Valentine arm. And that's what it's all about. So that's the sparge. Oh, on the right-hand side there, just that little snippet, that's just a picture of the wort coming out of that end piece there. So it gives you an idea of the kind of speed, I suppose. So this is at the end now. I've finished the sparge, and this is the grain baskets that I was talking about earlier. It's quite heavy. When it's got 5 kilograms of grain in it, that's absorbed 5 kilograms of water, and there's another 2 or 3 kilograms of water just kind of sitting in there. That's a lot of weight to lift, because this is kind of at my shoulder height. So I just use this kind of pulley because it's easier to pull down with my own weight to kind of help me than it is to lift up. So I pull this down and use these little clips here just to hook over the edge, and then rest the grain basket down on those clips. Leave it for 5 minutes or so, and then lift it out and just put it in a bucket to finish off the draining. The boil, relatively simple. I mean, you know, boiling wort. This here is me skimming off the hot break. I always skim off the hot break. That's a bit controversial. Some people say you shouldn't. Other people say that the clearer you can get your wort, the better throughout the whole process. So I kind of subscribe to that, and I mean, that's why I was doing all the lautering earlier and filtering through the grain bed, so I got that nice clean wort. Here I'm skimming off the hot break, so again, a nice clean wort. When it comes to adding the hops, I use one of these mesh bags, which I got from the supermarket. It's one of the kind of normal vegetable bags that you get in the supermarket. I put my hops in that. I use in this case, a 1-inch ball bearing. That just helps to weight the bag down so it doesn't just float on the top. And when I finished all the boil, I use a plate chiller to cool. So you see the wort comes through here, through the pump, up into the plate chiller, and then gets circulated back into the boiler. And the plate chiller is connected to the cold water supply, and then warm water goes back out to the drain. So that's all done. Once I've finished the cooling, I just let this sit for about 30 minutes to an hour to allow all the protein from the cold break to sink to the bottom of the boiler. And then I just connect this hose, drain it into a plastic bucket, which is my fermenter, add the yeast, give it a bit of a wallop, put the lid on, and fit the bubble trap, not having forgotten, of course, to take a reading. Into the fermenting cabinet, there's the cooling again. And then when it's fermented, I normally ferment for about 12 days, thereabouts. And I then, of course, take another hydrometer reading, and then I use an ordinary kind of siphon with a little mesh sock on the end just to stop any crap coming through, and siphon that into, in this case, it was the wooden barrel that I used just recently, but ordinarily that would be a keg, of course, corny keg. And that's me done. And that picture actually is a place called the Foundry in Canterbury, where they do lots of nice ales, and me tasting them.
Ooh. When are we all coming over to yours?
I know, I was going to say.
Sit at your bar.
Lab in-person meet.
You are all welcome anytime.
Are you available for hire as well?
No, I'm not available for hire.
No, your brewing shed, that's just amazing.
That's amazing.
An amazing bit of work. Yeah.
It was my retirement project. So I retired 2 years ago, and I needed something to stop me from going mad. So I was already brewing at that point, but I was brewing kits mostly. I think I just started doing some extract brewing, and I was mostly putting stuff into king kegs. And I thought, now is the time maybe to start doing something a little bit more ambitious. And so I built the brew shed and started dabbling with cornies and all the stuff that goes with them, all the plumbing and gas and so on.
Did you have a background in that, or did you learn it as you went along? Building a brew shed and the cooling.
I have an engineering mind. I have an engineering mind, I suppose. I was in the Air Force, Royal Air Force, as an aircraft technician. So I know about electronics. I'm generally quite handy, practical skills wise.
Yeah.
So the combination of being trained in electronics and computing, having good practical skills, all kind of melded together quite well.
Yeah.
And having a thirst for beer.
Good stuff. Very impressive.
So I think that's me done. I think we're over to you, Mick.
I don't know if we can run it on 2 devices at the same time, can we?
Yeah, you should be able to.
Okay, because I'm on the PC at the moment, and the tablet's sitting in the garage stroke brewery. So
Well, either
I'll,
drop
change
out and then
seats.
drop back in. But
yeah,
I mean,
see, I've got my phone with the passcode and things on. So
Les, I don't know. Do you want to just quickly go through your presentation slowly, just so anybody can ask questions on the way?
Oh,
I didn't want to disturb you in full flow.
oh, that's
Yeah.
fine. Sorry. Yes, mind you, slowly. That's going to take you the rest of the night.
Well, I just mean to sort of zip through them. So it was just more looking at the actual the brewing setup and things like that. It's, yeah, I'm very impressed by the shed and everything, and that's definitely a if I ever have to move away from where we are at the moment, then and then potentially move up north, and that's definitely on.
So there's the first slide then.
Yeah.
North, I'm in Maidstone. I'm south of you.
No, I mean north as in well, the point is, like, if I ever have to move up to near Manchester, where my wife's family is from, then there's not going to be much outdoor brewing up there.
Ah, right. All my brewing is outdoor. I brew on the bar. So yeah, I brew outdoor because of the steam mostly. Okay, so this is the construction.
Yeah, well, just go through the slides, tap through them, and then people can jump in if they want to ask anything. I think.
Do you have any wastewater provision, or do you have
Yes.
any, right?
Yeah. So here you see there's a pipe.
Yeah.
And here there is a pipe, and then
Right,
another pipe there.
Got you.
That's the wastewater. So at this point, coming under the ground to prevent freezing, I suppose, and up here is the water supply. The wastewater comes along here, sloping down, and then through the ground here, down to my drain that's just outside the house. So where I've got an outside tap, that's the supply for this, and the drain underneath it is where all my wastewater ends up.
Right. So you've been sort of taking a loop off the outside tap almost, taking, and then wastewater's coming back into the same drain as the tap.
Yeah. So
right.
Where the pipe comes out of the house, I've put a T-piece. One end goes up to the tap, the other end goes down into the ground, and then off to here. And obviously the whole thing is turned off through the winter when I'm not brewing. I turn it on when I brew. And on the route to here, there is a T-piece that goes off to a drain tap. So in the winter, I just open the tap, it drains the pipe work. So I've got.
So you won't get any freezing then, yeah.
No, that's right. So that drains the pipe work. And then when I'm doing a brew, obviously the tap is closed off. I open the valve to allow water through, do my brew, and at the end, I drain the pipe again, if need be.
Yeah. Oh, neat. Yeah.
So that was part of the building.
How long did it take?
Well, I did this as part of a garden refit, so you can see that there's stuff going on perhaps on the garden as well, like here, for example. So this took the whole of a summer. I did it all myself, and I didn't use any power tools. I use power tools. I didn't use any heavy tools like diggers and things.
Wow.
So I just enjoyed the experience because I just
Yeah,
retired,
cool.
and I like kind of doing physical stuff as well.
Yeah.
Did
So I
did you mix the concrete yourself?
Yes, although I did use a concrete mixer
Oh, that's all right.
because I had a lot of concreting to do. I had raised beds to build. I had decking to do. I had all of this concreting to do. There was a lot more concreting to do than you can see.
No, it makes better concrete anyway.
It would have taken me another 6 months, I think, if I'd done it all by hand. All that paving, of course, is laid on concrete.
Yeah.
As well.
Oh, it's brilliant.
And here, all of this decking. You can't see much there, but there's an awful lot of decking there.
Right.
And all of that is laid on basically a concrete raft, and then the framework is all built on top of that. Oh, and I mentioned earlier 2 cables that came up. That was on this first slide here, 2 cables. One provides all the electrics for the brew shed. The other one provides the lighting that's responsible for all of this lighting here and on every post around the garden and so on here.
Mm.
And all of that comes on with one switch in the house. So we just in the house flick the switch and all the garden lights come on, which is quite nice. Because we do that, we put, they're all LED lights. So in total, there's hundreds of watts of light power, but it's actually only about 100 watts of electricity. So the same as a 100-watt bulb lights up the whole garden.
And is there any provision for enclosing that outdoor area there, Les, or is it just designed as like a summer entertaining space?
I've got. You won't be able to see it on here, but all the way down this post, there are inset brass screw threads. And I can put a clear PVC tarpaulin on this wall and on that wall over that side. This one is never closed off, but I can do that one and that one. And I call that my winter plumage. Because at winter time, that's what I put up if I want to still brew in the winter and not be cold.
That's great.
Mm.
You might even be able to see it on one of these. Oh no, you can't. Oh, here we go. Yes, you can see it there. Can you see the sheen that there's actually the plastic sheets there? I left that one on even in the summer because of this was COVID. So that was kind of protecting me against the neighbours and vice versa, because they've got a patio area on the other side of that hedge there.
That was like your airlock to the pub.
Yes. Yeah, that's right.
So your actual, I guess you said you got your brewing your Signet boiler. Is that, where's that stored?
It's stored in the garage. So when you saw all this stuff, there's another shelf up here, and on top of that is where on the very top shelf is where all my kit is kept. So the boiler, all the buckets and things for fermenting and so on all sit on top of that.
Lovely.
So I think we got somewhere around there. So that was all the insulation stuff.
I was just interested by the radiator thingy about the difference between sort of sucking and pushing.
Yes.
I didn't quite catch what you were saying about that.
These you see these kind of little holes here. They are, if you try and push air into them, they create a back pressure because there's quite a lot of metal compared to hole, and the metal pushes back. You kind of get the air reflecting back off the metal that you're trying to. Is that
how it's normally set up in an actual car radiator as well, or have you flipped it around for?
I think car radiators are actually the same. So this is a car
Mm.
radiator, and I think car radiators might suck as well.
They used not to, but I think you're right. It's the same thing with computer fans, because I was messing around with some computer fans to try and cool a fridge actually, and it wasn't. And there was quite a lot of discussion about push and pull and so on. And I think it's the same thing with. You'll see it on some fridges themselves, where they've got the evaporator coils at the back. I think they've got a similar thing where pulling through works better. I think if you look at certainly the compressor fridges, a lot of them pull the air through rather than trying to push against almost a flat surface. That causes turbulence.
It does, and I can absolutely tell you from my own experience. I did have the fan on the other side pushing, and what happened is that the whole thing just froze. The whole radiator just froze, which is why I built this defrost cycle. I didn't have this here to start with, but I built it as a way of helping this to defrost. But that was before I'd cottoned on to the fact that actually all that was happening was that the air I was trying to push through the radiator was actually just bouncing off it, and it wasn't going through. You could feel a little bit of air coming through, but not very much. But when you put this on the front of the radiator and suck, there's a gale of ice cold air that comes out of it. So it is the answer. You have to suck through those things.
Yeah.
That's great.
And that removed the problem of it icing up then?
Yeah, I had no more icing up, so that's redundant. That's completely redundant now.
Yeah.
Is that why it's in guttering, Les? Is that was for like condensation or defrosting? Yeah.
Yes, you do get, even with the suck, you still get, because this is I've not got the fan covering the whole of the radiator, of course, but this gets to -3. So you can imagine that any air that's kind of in the brew shed that's not already completely dry, you immediately pour the water out of it and it just runs down here as condensation. And so this was needed. I didn't know that it would be to start with, because I thought maybe there won't be much wet air inside the brew shed, but surprisingly, every time you open the door, you have a bit of an exchange of air and there's more moisture gets in. You've also got fermenters in there that are throwing out moisture. So moisture comes from, I don't know where, pretty much everywhere it seems.
People breathing as well.
People breathing, yeah, they should stop that. So yeah, I had to put this bit of guttering here, and it's piped off down here to get rid of the water that is produced from the condensation. But yeah, that was necessary.
It sounds like a very efficient system, though, from the graph that you showed.
It's pretty good, yeah. When you bear in mind that that it's only one little maxi chiller. It's 500 watt maximum, but it's managing to keep the whole of that brew shed and my fermentation cabinet and the Python and the product to an extent cool in 36, 37, 38 degrees of heat. The first thing that gives up actually is the product coils, because they're immersed in the water bath. So if you're making frequent demands on the water bath to cool down the brew shed and the fermenter, the water bath starts to warm. So where it would be -3, it becomes kind of +3, +4, and then your product coils don't chill the beer, lager.
Awesome.
Amazing.
Shall I stop there?
I think we could talk a lot more about it, but I guess we'll stop there for now, and maybe we can have a revisit at some point.
Yeah, we can come back. We can come back. But I don't want to take
yeah.
over the whole of the evening. We'll come back to it by all means.
Thank you very much, Les.
You're welcome.
Nice work, Les.
Thank you, Les.
Yeah, let's let Mick have a go, and then we can
Yeah.
come back to me if you want to ask any more.
So in a couple of months' time, Mick is going to be doing a presentation on building his brew shed, and it'll be, I guess, you can also get some input from your experience as well, Les. But But yeah, Mick, take it